guys, Miss Venable here, bringing you some kitchen chemistry, and today we're going to be working with M&Ms. If you are remote, I will be taking the data for you. If you are in person, you're going to get your own little fun-sized M&M pack to work with. So we're going to pretend like this is a chemical compound, and it has different components, which are the different colors. So you've got red, orange, yellow, green, blue, and brown components. And we need to figure out how many moles of each. So one M&M counts for 1 mole. So now that we know how many moles we have for each type, we can write our empirical formula. Remember, an empirical formula is the lowest ratio of all the moles. And our numbers are 8, 13, 8, 15, 11, and 4. Now, these are all whole numbers, which is what we want for a mole ratio, and you can't divide anything into all of them, so they're already the lowest ratio. So now we can just write our empirical formula using the lowest whole number ratio that we got. So I can write R subscript 8, O subscript 13, Y subscript 8, G subscript 15, BL subscript 11, and BR subscript 4. So that's the empirical formula for the compound in my M&M pack. Next, we're going to figure out the masses of each of these. And so we're going to assume, they tell you in the discussion, assume that the molar mass for the red is 1, the molar mass for the orange is 2, the molar mass for the yellow is 3, and so on. So we need to take each one of our moles and convert it into grams using those molar masses. So here we have 8 moles of red, and if I want to convert it, I just need to do a bar and a line. And I know that 1 mole of any substance has a mass equal to its molar mass. And they told me the molar mass for the red was 1.00 grams. So 8, the moles cancel. 8 times 1 is 8 grams. So the mass, and I need 3 digits, so 8.00. Okay, and you guys are going to repeat this process for the orange, except the mass of each orange is 2 grams. And for the yellow, the mass of each yellow is 3 grams. And the green, you would use 4 grams, and the blue, 5 grams, and then the brown, 6 grams. So repeat that process. So now that I know the mass of each of the components, I can just add them all together, and that's going to give me the empirical mass of my compound. So you're going to add up 8.00, 26.0, 24.0, 60.0, 55.0, and 24.0, and you'll write that as the empirical mass. So next we're going to find the percent composition for every element. And remember, percent composition will be the mass of each one divided by the whole mass of everything, which you just figured out was 197. So let's take a look at that data. So for the red M&Ms, we figured out that the mass was 8.00. And the total mass of everything is 197. And we're going to multiply by 100, and both of these are grams, so they cancel out. So in my calculator, 8.00 divided by 197 gives me, times 100, gives me 4.06%. Okay, so we're going to repeat that for all of them using each one's individual mass. So for the orange, its mass was 26.0 grams divided by 197. Grams cancel, times 100. And my calculator says 13, and I'm rounding a little bit here. It's 13.19, but I'm rounding to 3 digits, so 13.2% for that one. Okay, so you just repeat this process for all of your colors of M&Ms. So we found out in the lab that our empirical mass is 197. But what if we did an experiment and we found out that the actual mass of our molecule was 3 times as much? What influence would that have on the formula? Well, it wouldn't be an empirical formula anymore. It would be a molecular formula. And so what you would do there is just multiply all your subscripts by 3 to write your molecular formula. So let's take a look at that. And also, you would change your mass, right? Instead of being 197, it would be 3 times more. So you would multiply that by 3 as well. So let's take a look at that data. Okay, so here's our empirical formula. And the subscripts are 8, 13, 8, 15, 11, and 4. So if our molecule is not the lowest ratio, then I have to have a multiplier, and they tell me the multiplier is a 3. So you want to write the molecular formula, which means you just multiply each of these by 3. So it wouldn't be R8, it would be R24 for your molecular formula. So you just do that to all of them. Now for your empirical mass, if it's not the mass of the lowest ratio, then it's called a molecular mass. And so if it's 3 times as much stuff, then it's going to be 3 times the mass. So instead of empirical mass, it'll say molecular mass, and you just multiply the 197 by 3. So that lab was pretty simple because just by counting the number of M&Ms, we started out with a whole number ratio, and we got lucky that it was the lowest ratio possible. When you're actually counting your own, you might have to divide by 2 or divide by 3 in order to get the lowest whole number ratio. So in the extensions, we're going to go a little bit further. Instead of counting or weighing, I'm going to give you percent compositions. So just pretend that you have a 100-gram sample and you can change all of your percentages to grams and then convert into moles. And then everything after that is exactly the same like you did it in the lab. So have fun with your M&M Lab. Thanks so much for joining me. Bye.